Mendel's experiments, the origin of genetics. So Mendel's experiments with pea plants involved many monohybrid crosses. A monohybrid cross is a cross that involves one pair of contrasting traits. For example, crossing a pea plant with purple flowers and a pea plant with white flowers is a monohybrid cross. Mendel used pea plants because they are easy to grow, they produce many offspring in a short time frame, and each of their traits comes in two clearly different forms, so it was easy to study. Using pea plants, Mendel was able to test patterns of heredity seen in multiple generations. He performed thousands of tests, and over the course of his experiments, had nearly 28,000 pea plants in the monastery gardens. Mendel's experiments can be summarized into 3 steps. Step 1. Mendel determined which plants were true bred by allowing pea plants to self-fertilize for several generations. If the plants were true bred, then all of their offspring would only exhibit one form of a trait as well as their offspring's offspring. Basically, it means that they were clones of each other. For example, a pea plant with purple flowers should only produce more purple-flowered plants over multiple generations. Once Mendel had 2 true-bred plants with contrasting traits, he would use these plants as the parental, or pea generation, of his experiments. Step 2. Mendel cross-fertilized the 2 pea generation plants by doing a monohybrid cross and examined their offspring, which he called the first filial, or F1 generation. So this is like the first group of babies. He kept a detailed count of the F1 plants expressing each type of trait, whether they were purple or white. Step 3. Mendel then allowed each F1 pea plant to self-fertilize. He called the offspring of the F1 generation the second filial, or F2 generation. This would be like grandkids. He counted and recorded the traits seen among the F2 generation.